Question number 121. The megasporangium of Pinus mainly consists of: first option, nucellus, protected by female gametophyte. Second, integument, having single archegonia. Third, nucellus, protected by single integument. Fourth, several archegonia and not protected by any integument. The megasporangium of Pinus. What is megasporangium? It is ovule. The another name for ovule is megasporangium. So it is not something which is difficult. It is just the ovule. So it consists of, see, here you can see this is the ovule of the megasporangia of the gymnosperms. Now, as Pinus is a gymnosperm, you can relate this ovule to the Pinus too. This is the nucellus which is shown over here. This is female gametophyte present in the ovule. These are archegonia inside the ovule, and this is the integument which protects the body of the ovule. So, first option, nucellus, protected by female gametophyte. The megasporangium consists of nucellus, but it is not protected by female gametophyte. Female gametophyte is present inside the ovule. So this option is ruled out. Second is integument having single archegonia. You can see here it is not the single archegonia. The Pinus contains 2 to 8 archegonia. So this option is also ruled out. Third, nucellus protected by single integument. Yes, you can see here it is the nucellus which is present over here, and it is the integument which protects the ovule. So this option is correct. The last one is several archegonia and not protected by any integument. No, they have integument. They are protected by integument. So the correct option for the given question is option number 3. Let's move on to the next question. Question number 122. There are 3 generations in gymnospermic seeds. Which of the following represents parental sporophytic generation? First option, endosperm and cotyledons. Second, perisperm, testa and tegmen. Third, plumule, radicle and suspensor. Fourth, cotyledon, endosperm and plumule. See, the gymnospermic seeds represent 3 generations. The parental sporophytic generation, the future sporophytic generation, and the gametophytic generation. So, which of the following structures in the options represent the parental sporophytic generation? See one by one. Endosperm, it is the gametophytic generation. Cotyledon, it is future sporophytic generation. So this option is ruled out. Perisperm, testa and tegmen, these all structures represent the parental sporophytic generation, as perisperm is the persistent nucellus which is from parental sporophyte, and testa and tegmen are the seed coats which are formed from the parental sporophytic tissues. So this option is correct. Third, plumule, radicle and suspensor. Plumule, radicle and suspensor all represent the future sporophytic generation. So this option is also ruled out. Cotyledon, again future sporophytic generation. Plumule, again future sporophytic generation. Endosperm is again gametophytic generation. So the correct option for the given question is option number 2. Let's move on to the next question. Question number 123. Ephedra is placed in: first option, cycadales. Second, gingoales. Third, knee-tails. Fourth, coniferales. Ephedra, along with neetum and welwitschia, is placed in knee-tails. This is very easy question. In cycadales, there is cycas. In gingoales, there is gingo, biloba, and many more. In coniferales, it is conifers or the Pinus. So these are the 4 orders of the gymnosperms. So the correct option for the given question is option number 3. Let's move on to the next question. Question number 124. Tonoplast, the membrane of sap vacuole, can be categorized into which of the following type on the basis of permeability? First option, selectively permeable. Second, impermeable. Third, completely permeable. Fourth, permeable only for larger molecules. The tonoplast is the membrane of sap vacuole found in plants, and the membrane is selectively permeable. It allows the movement of some selective solutes and solvent molecules, hence it is selectively permeable. It is not impermeable, otherwise the cell will be dead. Third, completely permeable. No, it is not completely permeable. Permeable only for larger molecules? No. So the correct option for the given question is option number 1. Let's move on to the next question. Question number 125. Two cells A and B are adjacent to each other. The cell A has osmotic pressure 13 atm and turgor pressure 5 atm, while the cell B has osmotic pressure 6 atm and turgor pressure 2 atm. The result will be, first option, movement of water from A to B. Second, movement of water from cell B to A. Third, equilibrium of water transport between cell A and B. Fourth, no movement of water at all. Here in the questions, two cells are given. We can consider here it is a cell A and this is the cell B. In cell A, the osmotic pressure OP is 13 atm and the turgor pressure is 5 atm, whereas in cell B the OP is 6 atm and TP is 2 atm. There's a formula you can recall that dPd is equal to OP minus TP. By applying this formula, the dPd over here will be 8 atm, 13 minus 5, and dPd over here will be 4 atm, 6 minus 2. Water moves from low dPd to high dPd. So from cell A and B, which has a lower dPd, the cell B. So water will move from cell B to cell A. So see the options. Movement of water from A to B? No. It is not from cell A to B. It is from B to A. Second, movement of water from cell B to A? Yes, it is correct. Third, equilibrium of water transport? No, there will be no equilibrium. There will be transport of water. Fourth, no movement of water? No, there will be movement. So the correct option for the given question is option number 2. Let's move on to the next question.